Okay, guys, so today's lesson, conservation of mechanical energy. So the formula for the conservation of mechanical energy states that the initial mechanical energy is equal to final mechanical energy. And this is true in the absence of friction. So we have initial mechanical energy equals final mechanical energy. What does mechanical energy means? It means the initial mechanical energy will be equal to the initial kinetic energy plus the summatory of the initial potential energy. Remember that for potential energy we might have a gravitational potential energy and or elastic potential energy. So again, initial mechanical energy is equal to the initial kinetic energy plus the summatory of the initial potential energy equals final kinetic energy plus the summatory of the final potential energy. So initial kinetic energy is equal to 1/2 mass times initial velocity squared plus potential energy mass times gravity times initial height equals 1/2 mass final velocity squared plus mass times gravity times height. So in these types of problems that we're going to be discussing, okay, when we have a certain height, a mass at a certain height, let's suppose that we have this mass, okay, and then we cut this string, right? We cut it from here. Initially, this mass will have its initial mechanical energy will be equal to the initial potential energy. Why? Because at this moment, this mass, once we cut the string, its initial velocity is equal to 0. That means that the initial potential energy is equal to 0. As when this mass is starting to fall down, it's falling, okay, in this motion over here, the kinetic energy will be increasing and the potential energy will be decreasing. So here at ground level, the mechanical energy will be equal to the final kinetic energy. Why? Because at this height, h equals 0, the final height is 0, so all the energy is being converted to kinetic energy. And everything over here in between, from the maximum height to the lowest height, the energies, the summatory of both energies will be equal. The initial mechanical energy will be equal to the final mechanical energy. So if we look at example problem E, it says, okay, starting from rest, a child zooms down a frictionless slide from an initial height of 3 meters. What is her speed at the bottom of the slide? Assume that she has a mass of 25 kilograms. Okay? So we have a child, this is the slide, and we have an initial height of 3 meters. Okay, the child is starting from rest. That means that the initial velocity will be equal to 0 meters per second. Okay, now we need to find the final velocity at the bottom of the slide. So we need to find final velocity at the bottom of the slide. That means that the final height at the bottom of the slide will be equal to 0 meters. Okay? Now, notice something important. If you notice, the mass is given as the last in the last sentence. Why? Because we don't need mass in order to solve these problems. We can neglect the mass. Why? I'll show you why right now. If we solve this equation, okay, if we solve this problem, we need to find final velocity, right? We know that the initial mechanical energy has to be equal to the final mechanical energy. Now, initial mechanical energy is initial kinetic energy plus initial potential energy equals final kinetic energy plus final potential energy. Okay? Right? Now, what information is given? We know the initial height, 3 meters. We know the initial velocity, 0 meters per second. We know the final height, 0 meters. And we're looking for final velocity, assuming that the mass equals 25 kilograms, right? Okay, that is the information known. Now, going back to the formula. What is initial kinetic energy? 1/2 mass times initial velocity squared plus mass times gravity times initial height equals 1/2 mass times final velocity squared plus mass times gravity times final height. Notice on this side of the equation we can factorize. We have mass in common, so we can factorize m times 1/2 initial velocity squared plus gravity times initial height equals, and we have mass as common factor here. We can factorize again, mass times 1/2 final velocity squared plus gravity times final height. Now we can divide by mass on both sides of the equations, and notice what happened. We can disregard mass on the equation. Why? Because mass is a common factor of the equation, right, on both sides. So this is why it doesn't matter the mass given. Okay, the answer will be exactly the same answer here for final velocity. Okay, this is why mass is not necessarily important in this problem. We don't need to know the mass. Okay, this is why. So going back to this equation, okay, we're gonna go back to the original formula. Now, the initial velocity is 0, right? So we can cancel this because 0 times anything is equal to 0, right? And final height is 0. So we can cancel this part over here. So what do we get? Mass, okay, times gravity times initial height is equal to 1/2 mass final velocity squared. So let's solve for final velocity. First, we multiply times 2 both sides of the equation, and we get 2 times mass times gravity times initial height equals mass times final velocity squared. Now we divide by mass. Notice we cancel mass. We didn't need the mass. And we get 2 times gravity times initial height equals final velocity squared. We don't want final velocity. Final velocity squared. We want final velocity. So we have to square root on both sides of the equation. So we get that final velocity equals the square root of 2 times gravity times height times initial height. Okay? Now let's substitute. Final velocity equals the square root of 2 times 9.81 meters per second squared times the initial height, 3.0 meters. Okay? So 2 times 3, that's 6, times 9.81. Okay? And then we find the square root, so we get that the final velocity at the bottom of the slide will be equal to, we're going to estimate our answer to 7.67. Sorry. Final velocity will be about 7.67 meters per second. And that will be the final velocity at the bottom of the slide. Okay? And that's it. So your assignment will be practice E, sample problem E, page 177. So the assignment will be practice E, page 177, problems 1 through 5, all of them, and chapter review, page 186, problems 35 and 36. Okay, guys, this is your assignment for this week. Okay, don't forget, if you have any questions, text me or call me, okay? Bye, guys.